Dr. A. Anita, Assistant Professor of Chemistry from VV Vanniyaperumal College for Women, Virudhunagar. In the previous model, we have seen about the gaseous state 1, in which we have seen the characteristics of gaseous state and the important parameters involved in it and the Boyle's law, and then about the Boyle's law. In this module, we will see that some other gaseous laws like Charles' law, Gay-Lussac's law, Avogadro law, and then derivation of the ideal gas equation. That's the equation of the state. In the Boyle's law states that we have seen already that there are three parameters which discuss the state of a gas. Among them, pressure, volume and temperature are the most important one. The Charles' law states that at constant pressure, the volume of a fixed mass of a gas is directly proportional to the Kelvin temperature of absolute temperature. If the absolute temperature is double, then the volume is also double. In the Boyle's law, we have seen the relationship between the pressure and the volume. In the Charles' law, we have kept the pressure as the constant value. Therefore, the variation is between the volume and the temperature. If the volume is increased, then the temperature is also increased. That is the relationship between. That is, the volume is directly proportional to temperature, whereas keeping the number of moles of the gas and the pressure as constant. That is given in this type of equation. That is, V1 is proportional to T1, or otherwise V1 divided by T1 is equal to a constant. The proportionality is removed by a constant. Therefore, if K is a constant, then at some other temperature, as temperature is increased, the volume is also increased. That is, the increased volume is V2 and the increased temperature is T2. Therefore, V1 divided by T1 is equal to V2 divided by T2. This is the mathematical expression for the Charles' law, and it is explained in this figure. Here, the volume of the gas is 0.5 liters, whereas the pressure is kept 1 atmospheric pressure. The temperature is 200 Kelvin. Here, the same volume of the gas, when the temperature is raised, the same pressure is maintained. Therefore, the pressure of these two components will be the same. On heating, as temperature is increased, that from 200 Kelvin to 400 Kelvin, the volume increases from 0.5 liters to 1 liter. As the temperature is double, the volume is also double. This is the experimental verification of the Charles' law. On plotting volume versus temperature, as temperature increases, the volume also increases. That is, its volume is directly proportional to the temperature. This is the graphical representation of the Charles' law, and this is the experimental verification for the Charles' law. Next, we see about the combined gas law. That is the combination of the Boyle's law and the Charles' law. The Boyle's law is given as volume is inversely proportional to the pressure, whereas the Charles' law says that when pressure is kept constant and the number of moles of the gas is kept constant, the volume is directly proportional to temperature. Now we have to combine these two gas laws. That's the Boyle's law and the Charles' law. That will be written as volume is directly proportional to temperature and inversely proportional to volume. Here, the number of moles alone kept as constant. This proportionality is replaced by multiplying it with the constant K. That is, the proportionality can be replaced by the constant. Therefore, V is equal to KT divided by P. On rearranging this equation, what we get is PV divided by T, which is equal to a constant. If the pressure, volume and temperature is at the initial state is P1, V1, T1 and at the final state is P2, V2, T2, then the combined gas law is given as P1, V1 divided by T1 is equal to P2, V2 divided by T2. This is the mathematical expression for the combined gas law. Here, the combined gas law states that if the mass is fixed, the volume is directly proportional to the temperature and it is inversely proportional to the volume. That is, P1 V1 divided by T1 is equal to P2 V2 T2. Next, we see about the next law, that is the Gay-Lussac's law. In this Gay-Lussac's law, we have kept the volume as constant. Therefore, the relationship is now between the pressure as well as the temperature. If the volume is kept constant, the pressure of a gas, the mass is also a constant. Therefore, the number of moles of the gas remains constant. Therefore, at constant pressure as well as the constant number of moles of a gas, the pressure is directly proportional to the Kelvin temperature or absolute temperature. And this is the mathematical expression. Volume is kept constant, number of moles is also kept constant. Therefore, the pressure is directly proportional to T. The proportionality is replaced by a constant proportionality constant, that is P by T is equal to constant. If the pressure is increased from P1 to P2, then the temperature is also increased from T1 to T2. This is the mathematical expression, that is P1 divided by T1 is equal to P2 divided by T2. This is about the Gay-Lussac's law. Then we go to the Avogadro's law. The Avogadro law states that equal volume of all gases. Equal volume of all gases infers that V1 is equal to V2 at the same temperature and pressure, that is P1 is equal to P2 and T1 is equal to T2. If this is the case, when the pressure remains the same, volume remains the same and temperature remains the same, then equal number of moles of gas, then there will be equal number of moles of these two gases. When we are comparing two gases with equal volume, equal pressure and equal temperature, then the number of moles of the gas will also be a same one. If the molar amount is double, the volume is also double. If the pressure is double, the number of moles is also double. That is given as the Avogadro's law. That is, if two volumes are same, then the number of moles also the same when under the condition of constant pressure, temperature, etc. Therefore, it is given as V1 is equal to V2 when N1 is equal to N2. Here we are keeping the volume as 22.4 liters under the case of 1 atmospheric pressure. Here the same 1 atmospheric pressure, the temperature is also remains the same. When the volume is increased from 1 mole to 2 mole, the volume occupied by them will also be increased by 2 times, that is it gets double. The volume increases from 22.4 liters to 44.8 liters and increasing the number of moles from 1 mole to 2 moles. This is the Avogadro law and this is the mathematical expression for the Avogadro law. When V1 is equal to V2 if N1 is equal to N2, or otherwise if N1 is equal to N2, then the volume remains the same at the two states. Now we have to see about the molar gas volume. That is, molar gas volume is nothing but the volume occupied by 1 mole of the gas at standard temperature as well as the pressure. And this is the term mostly used by the scientists in order different countries have different temperatures as well as the different pressure of the gas depending upon the area it is located. If it is in a hilly region, its atmospheric pressure is different, and if it is nearer to the sea level, the pressure will remains changed. Likewise, the temperature of the nations will also be varied to some extent. Therefore, the scientists use a standard term, that is the standard temperature as well as the standard pressure, that is given as standard temperature. Pressure is abbreviated as STP. The standard temperature is considered as 273 Kelvin and the standard pressure is considered as 1 atmospheric pressure. Then at 1 atmospheric pressure and the standard temperature of 0 degrees centigrade, what the volume occupied by 1 mole of a gas is called as the molar gas volume. At STP, any kind of gas occupies 22.4 liters. That is the volume occupied by 1 mole of any gas like oxygen, nitrogen or carbon dioxide. It will occupy only the volume of 22.4 liters. This is the molar gas volume. Next we come to the ideal gas equation. In the combined gas laws, we have combined both the Boyle's law as the Charles law. For the ideal gas equation, we have to consider 3 laws: Boyle's law, Charles law as well as the Avogadro law. As previously seen, the Boyle's law is the mathematical expression for Boyle's law is V is inversely proportional to the pressure. Volume is inversely proportional to the pressure when the temperature and the number of moles remains constant. Charles law indicates that volume is directly proportional to temperature when the pressure and the number of moles remains the constant, whereas the Avogadro's law indicates that volume is proportional to N when the pressure and temperature remains constant. Now we have to combine all these 3 laws and come to the conclusion of PV is equal to nRT, or otherwise P is proportional to T by V. That is directly proportional to temperature and inversely proportional to the volume. The proportionality can be replaced by the constant called as the R. That is called as the universal gas constant. And this PV is equal to nRT is termed as the ideal gas equation. That is, any ideal gas obeys this equation. Or we can come to the conclusion that if any gas obeys the ideal gas equation, then it is an ideal gas. If not, then it comes to a real gas. For 1 mole of a gas, the value of N is equal to 1, therefore PV is equal to nRT. For N mole of a gas, we can rearrange this equation as PV is equal to nRT. This ideal gas equation is otherwise termed as the equation of the state. Why it's called as? It involves all the state variables like pressure, volume as well as the temperature, which are connected together with the universal gas constant. In the next module, we will see about what is the gas constant and what is its significance and what's its value, and some other gas laws like Dalton's partial pressure equations and some other things. Thank you.